in this field. Please have the floor. Thank you.
Thank you. And thank you for the invite to come and present this topic at this meeting. It's a big honor. The topic is safety assurance for advances in long-term operation, with a particular focus on the contributions made by 5 European Commission funded projects and New Genius supported projects with a particular focus on structural integrity. So to see how this is going to work, this is what we're going to be doing. First of all, I'll introduce you. There's only one slide, but I'll introduce you to the project portfolio that is covered by this presentation. As I say, there's 5 projects that we're going to be thinking about. Then we're going to look at an overview of nuclear industry operational issues. Some of these, in fact many of these, have been covered quite a lot this morning and already this afternoon, so we will be reminded of those in this context. And we'll see what sort of challenges they bring for long-term operation, and in particular, what contributions the projects have been able to make to meeting those challenges. You'll see as we go through all this that there's been a substantial amount of international engagement, that is to say engagement of all these projects with agencies outside of Europe. And that's quite exciting, it's quite important, and so we will talk about those. And of course, we'll look at remaining challenges before we summarize the talk. So, the project portfolio. INCEFA-PLUS. The first thing I would say is the value. These are just 5 of the projects which would have been on the slide in the previous presentation of New Genius projects. 4 of them are ongoing, and 1 of them is now finished. But the combined value of these projects in terms of European Commission funding and national funding, because in most of these cases there's a substantial amount of national funding to complement the European Commission funding, I've worked out is about 28.5 million euros. So it's a substantial value just for these 5 projects. So INCEFA-PLUS. INCEFA-PLUS focuses on environmental assisted fatigue. There are 16 organisations in this project. It's been working the consortium's been together since 2013, and the current project is finishing next year in 2020. It's focused on responding to US NRC guidance on how to do environmental fatigue lifetime assessments and how to allow for the effects of water, and in particular how to respond to some significant perceived conservatisms in those rules. SOTERIA is focused on, which also started in 2015 but is finishing this year in 2019, also is a consortium made up of people who've been studying the effects of radiation damage on materials, reactor pressure vessel materials, and also internals. And there was talking about irradiation-assisted stress corrosion cracking. That project is focused very strongly on developing a mechanistic understanding, so that you can then extrapolate to long-term issues. MEACTOS is a newer project. It started, I think, in 2016. And that is looking at the effects of surface condition on stress corrosion cracking, and in particular addressing there is a perceived over-reliance on the use of surface roughness measurements to decide on whether a surface finish is acceptable or not. And for stress corrosion cracking, there are many other things such as residual stress measurements just below the surface, which also affect stress corrosion cracking susceptibility. And MEACTOS is developing a mechanistic understanding of those influences on cracking susceptibility, and also testing new innovative machining techniques which might help to mitigate the cracking susceptibility. ATLAS-PLUS is quite a bit different to the first three projects in that it's not an environmental cracking focused project at all. ATLAS-PLUS is looking at leak before break type assessments and ductile tearing assessments. And it's also a project which started in 2016, so it's still running. It's about halfway through, and that's focused on the use of probabilistic techniques. To really, these are very much beyond design code type assessments, helping plant assessors show whether or not a structure will fail benignly or catastrophically. There's some very, very large-scale experiments, complemented by a lot of small-scale experiments being done within ATLAS-PLUS. And finally, we come to Nugenia Plus, which has already been mentioned in the previous presentation. This is a little bit different. It's finished now, but it ran until I think it was 2016. And a lot of the funding in this was for pilot projects, very small pilot projects, addressing a whole raft of technical subjects, and you can see them listed on the slide here, from inspection technologies, stress corrosion cracking. I think there's even some soil mechanics in there, database type issues. In small pilot projects, those were able to show whether or not there could be benefit from a much larger scale activity. And in fact, many of those small pilot projects did become the precursors to some of the larger projects that I've already described. So, nuclear industry operational issues. We use the phrase long-term operation. What gives rise to long-term operational challenges? Well, I think there are four. They can be grouped into four rough areas. The first is economic. We've heard already today about the fact that the European nuclear fleet is aging, and without any action, there will be a reducing ability to generate electricity from the nuclear fleet. And so there is a strong economic driver to extend the life of the current fleet. We've also heard that it's taking time to bring new plants into service, and that just compounds the problem. So there are strong economic drivers for keeping the plant running as long as possible, long-term operation. There are also engineering issues. If you're trying to make a power station run for 60 or even more years, when it was only originally designed to run for maybe 25 years, clearly your materials are going to be experiencing conditions they were never designed for. And there are some potential problems for the materials listed on the slide here. So you have to be able to understand what the effects are going to be on the performance of the materials when you want to make the safety case to go to longer lifetimes than was originally being designed for. The third driver, I should say, is legislative. What do I mean by that? Most safety cases are, for very good reason, based on, as much as possible, on the existing design rules and assessment rules. And there's a very good reason for that, because those rules are often, they've been around for a long time, they're very stable, they're accepted around for the world by many, many people. And so there are very good reasons why plant assessors will, wherever possible, use existing design codes. But there are two particular sets of circumstances, two particular types of circumstance which can give problems. One is if you have a situation where you have a defect on your plant which is outside the design code, Well, with more work, you can sometimes step outside the design codes. But obviously, that becomes a long-term operation challenge. You've then got to do something innovative to deliver a safety case which a regulator will accept. The second legislative challenge, issue which can arise, is when a design code or an assessment rule changes. Mostly, these design codes and assessment rules evolve gradually. But every now and again, there can be step changes. And if we take the example of the environmental assisted fatigue that I was talking about earlier on, where the USNRC introduced a rule, that was a step change in how you had to do environmental assisted fatigue assessment. And it has created enormous problems. You can only counter those with good evidence, and so that becomes an issue that you've got to respond to by generating that evidence, either through testing or through modelling. The final category I've chosen to put up here is safety, and of course safety does underpin the first. It is also part of the first three of those issues, but it's worth talking about on its own as well. There is a very, very increased now public perception of nuclear safety. During the last century, there have been a number of reasonably high-profile nuclear accidents, not too many, but enough, to give the public very good awareness of the dangers of nuclear power if something goes badly wrong. And so quite rightly, we are expected to generate very, very high standards of safety confidence. And of course, that is one of the things we've got to have very much in our minds when we're producing safety cases for long-term operation. So, what's the project portfolio done to meet any of that? Well, the first challenge is how do you justify materials performance to beyond 60 years or even beyond. And there's some examples here of how 4 of these projects have met those challenges. INCEFA-PLUS is already improving environmental assisted fatigue predictability. It's taken a lot of that particular project's taken a lot of effort to think about how to carefully accelerate tests. That's an issue which is also common in SOTERIA and MEACTOS. You have to, in a laboratory, you cannot test a material for 60 years plus. You'll never get your answer. So you have to accelerate testing for all these technical areas, but you have to accelerate the testing intelligently, otherwise you will not get a result which is relevant to the issue you're trying to deal with. And there's also an emphasis in INCEFA-PLUS on very high statistical reliability, because we're talking about creating new assessment curves. SOTERIA is focused very strongly on mechanistic understanding, also to help you actually extrapolate to very, very long lifetimes, for example, of baffle bolt materials, which are susceptible to irradiation-assisted stress corrosion cracking. SOTERIA is adopting a multi-scale approach from a testing and a modelling perspective to allow you to actually understand what's happening at the microstructural level and the influence that has on the behaviour of whole structures. MEACTOS is dealing with how to understand the effect of surface finishes on stress corrosion cracking resistance. Obviously, for plant extension, you already know what your surface finish is, but if you can quantify that and measure it appropriately, you can then take a view on what that means for your stress corrosion cracking susceptibility. Eugenia Plus, well, the pilot projects have helped to set the scene for the other 3 projects, including SCC testing, machining effects. It's done some work on atom probe data protocols, which is also relevant to what's been going on in SOTERIA. One of the things I want to say before I leave this slide is a little throwaway comment at the bottom, and it crops up a little bit later again. All of these projects they're all quite big consortia, and they all benefit from a significant amount of European Commission funding, but they also have national funding. And you might say, well, why do they need the European Commission funding? Well, the answer, I believe, is that you can do an awful lot by bringing organisations together to work an entirely in-kind basis, and clearly that can happen. Some of these projects have worked in kind for some years before they benefited from European Commission funding. But the European Commission funding provides, that facilitates a level of coordination and consistency within these projects, which otherwise might be more difficult to achieve. And that's the key. That's the key. You bring these organisations together, and you create something which is much bigger and more powerful than the organisations any one of these organisations could create on their own. More statistically powerful, and also, courtesy of the independent funding, more of greater statistical relevance. This is also about materials performance, but this is about materials specification. So this is when you're choosing materials which you now want to justify will be operating for a long time. INCEFA-PLUS, I won't go into all the details again because otherwise we'll run out of time, but INCEFA-PLUS, for the reasons we've already discussed, is dealing with that. SOTERIA is helping to deal with that, and MEACTOS is helping to deal with that. And here we have some cross-collaboration between the projects, because MEACTOS and INCEFA-PLUS, both being focused on surface finish as one of the parameters of interest, are sharing how do you measure surface finish reliably, and how do you control surface finish reliably. Design codes and their fitness for purpose. I've mentioned already that design codes can be very useful, but they can also be a little problematical at times. Well, INCEFA-PLUS is clearly dealing with the EAF design codes, and MEACTOS is dealing with the issue of how do you measure surface finish in a way which is relevant to the degradation that you're worried about. And in particular, MEACTOS is dealing with the perception that surface roughness is the main parameter of interest. ATLAS-PLUS the design code fitness for purpose is very relevant to ATLAS-PLUS, because ATLAS-PLUS is developing very, very cutting edge assessment techniques, probabilistic techniques for pronouncing on the likelihood of ductile tearing and leak before break. And in order for an assessor to be able to use such techniques, you need a large body of data. And so ATLAS-PLUS is generating such a large body of data at a variety of scales, starting at the small scale and building up to, I think it's 5 demonstration tests on very, very large scale, full, they're actually X-reactive sections of piping. As I said earlier on, all of these projects, and Eugenia-PLUS, sorry, that's also been doing reactor pressure vessel integrity assessments. One of the Eugenia-PLUS pilot projects was dealing with that. As I said on a couple of slides ago, these projects all are able to deal with these issues because they're bringing together a large number of organizations, generating a large body of statistically relevant and useful data. The last, we're nearly at the end, justification for operation of structures. So this is the last bit. This is really, how does the structure fail? So if you get to the point where the structure is going to fail, you want to know that it's going to fail benignly rather than catastrophically. And ATLAS-PLUS is dealing exactly with that issue. Will a structure fail benignly, in other words, leaking, or catastrophically shattering. And one of the new Junior Plus projects was also dealing with that. We should mention, and I'll only mention it in passing because the talk immediately after this will be talking about these projects in a lot more detail, but of course, if we're talking about long-term operation, one of the things you have to be able to do is inspect the plant reliably. And so we should mention that there are projects which are outside the scope of this talk, but will be mentioned next in the next presentation, which are dealing with inspection reliability and modelling of inspection techniques. So as soon as that comes up next, I won't go through that in any more detail. The next challenge, and I think it's the final challenge before I start to summarize this, is people. If you want to make a long-term operation safety case, you need people, and you need people with the right amount of expertise. And there are two reasons why, and we've been hearing about these today, why that's somewhat problematical to this industry. One is the demographics. Pretty much throughout Europe during the 1990s in particular, there was very limited recruitment of people, and that's led to a demographics issue where there are a collection of people at close to or beyond retirement age, and a collection of people who are largely much younger, and not many people in the middle. That's obviously a challenge. Another challenge which we've also been hearing about today is the perception, and I shared the misgivings given earlier on about whether this is actually true or not, but there is a perception that the nuclear industry is not as exciting technologically as some other industries, such as aerospace, for example. And that is something we have to counter if we're going to attract people in. These projects all have significant dissemination activities as part of them. They have some of them have got grants for people to work in other organisations during the course of the projects. Many of them are sponsoring PhDs. All of them have at least a couple of workshops which are open for researchers and also new researchers to come and learn about what's going on in the project. And all of them are very active in presenting on the international conference circuit. All of that, of course, is helping to attract people into the industry and also retain them. International engagement. I mentioned at the start there's been some quite exciting developments. There isn't time to go into too much detail on this, but these four projects, the four current projects, have all in different ways proved to be very interesting outside of Europe and are attracting lots and lots of interest from outside Europe. INCEFA-PLUS is in the process of developing data sharing agreements with the US NRC and EPRI and the Japanese Nuclear Regulatory Association, JNRA, I think that's what it stands for. SOTERIA has organizations such as EPRI in its user group. MEACTOS has organizations from outside of Europe. I mean, you can see the names there. We've got, I can't read it from here, but anyway, you can see them on its user group. And ATLAS+ is forming relationships in the USA and Japan, Mitsubishi Heavy Industries and Oak Ridge in the case of ATLAS+. This is all, the reasons this is good is if you can get that level of interest and that level of engagement with people who have to travel quite long distances to come and meet you and talk with you, that means what we're doing is standing up to scrutiny and generating the interest. And also it means that when we develop advances which people can actually use for plant assessments, they are more likely to be internationally accepted because of this engagement. So where do these projects go from here? Well, INCEFA-PLUS is probably, that it will deal with the sensitivities that it's currently dealing with, but is probably going to be starting to think about focusing on scale effects. SOTERIA there are two strands of activity which are foreseen for the SOTERIA consortium if they can get the agreement as to how to proceed. One is looking at statistical significance and how do you actually store the data for long-term accessibility. And the other one is is there any way of using probabilistic techniques to actually get a better handle on IASCC susceptibilities? MEACTOS, by the time it finishes, will have come up with a view on how do you reliably measure and characterize surface finishes, and also which surface finishes are likely to give you the best benefit. But probably you would need more data then to actually fully parameterize that favorite surface finish. And that's possibly where MEACTOS would go off to. INCEFA-PLUS, that's a bit more difficult to foresee where that's going to get to, because it will produce some rules that plant assessors could use straight away. In fact, it already is doing. Some of the rules being developed with INCEFA-PLUS are already being used. But data accessibility could well be a challenge to be dealt with into the future, and there's probably still going to be some knowledge gaps. Am I saying here that these are subjects which are going to go on forever and ever and ever, because that's something that I know people are concerned about? Well, no, not necessarily. It's not necessarily the case. All of them are generating benefits now. The international engagement is a demonstration of those benefits already. What we're saying is that you can actually improve the benefits, and of course eventually you reach a case where the benefits aren't outweighed by the cost of them. So the takeaways from this, long-term safety assurance demands work on materials performance over extended periods, selection of materials for new plant, design and assessment codes and their strengths and weaknesses, structural performance, how an item might fail, inspection scheduling and techniques, availability of expertise. The required complexity of the work to address all of those issues and all the volume of data that's actually required is why you bring organizations together into these consortia. And the European Commission R&D support facilitates that, as hopefully I've managed to demonstrate. Thank you.
So my question was related to
Just trying to understand the question there. So you're talking about you make an advance, but how do you actually then make it so that it's going to be acceptable? Yeah.
So have you had situations like this in Europe, and how would you go around it?
Yeah, I mean, the subject I'm most familiar with in this is the environmental fatigue, so I'll answer it from that perspective. The USNRC guidance is well accepted, and people are using it all around the world and dealing with the conservatisms in different ways. We are trying to tackle in that project four particular sensitivities, and we are close to quantifying what those sensitivities are, and the quantification is somewhat different to what is currently in that USNRC code. The way we're dealing with that is we've got engagement with the USNRC so they know what we're doing, and we're being open, and what we will do is we will produce documentation which justifies our position, and we will then take it to the USNRC and hopefully get them to agree that this is something worth considering.